Dear students, this class, let me give an introduction on the subject antenna and wave propagation. The subject antenna and wave propagation deals with basic antenna parameters, its radiation characteristics, different types of antennas like array antenna, phased array antenna, helical antenna, log periodic antenna, rhombic antenna, and followed by different kinds of special antennas and antenna measurements over long distances. Antenna can be defined by considering this free space communication link. So in this free space communication link, you can observe a transmitter portion and a receiver portion. Antenna is an important communication tool. Without antenna, we cannot experience a long distance wireless communication. So this free space communication link consists of two antennas. One is transmitting antenna, other is receiving antenna. In the transmitting side, the generator is connected to a guided medium transmission line which is opened out before entering into the free space. In the receiving side, the receiver is connected to a guided transmission line which is again opened out into the free space. This guided transmission line contains a one-dimensional electromagnetic wave, and the transition region or the tapered section converts this guided electromagnetic wave into a free space three-dimensional wave. In the receiver side, the receiving antenna, which is the tapered section, converts the free space plane waves into a guided electromagnetic wave. So, here the antenna can be observed to be a region which converts an one-dimensional guided electromagnetic wave into three-dimensional free space radiating wave. So, this tapered section of the transmission line or the tapered transition of the transmission line can act as the region of conversion or as the antenna. Antenna has the property of radiating. So this structure will convert this one-dimensional wave into three-dimensional wave. Similarly, in the receiving side, this tapered section will act as a device or a structure to convert the free space wave into one-dimensional wave. So now we can define the antenna as a transitional structure between the free space and the guiding medium. Here the guiding medium is transmission line and waveguide. So the region of transition between the guided region and the free space wave propagation can be used to define the antenna. Antenna is basically a transducer which converts radio frequency energy into electromagnetic wave of same frequency. It will form the part of a transmitter as well as the receiver section. Alternatively, antenna can be a piece of conducting material in the form of wire, rod or any other shape with excitation. It can be a source of radiator of electromagnetic waves. It is a sensor of electromagnetic waves. It is an impedance matching device, or it is a coupler between the generator and free space and vice versa. So these are some of the ways of defining the antennas. Antenna radiates whenever there is a discontinuity or open end exists in the wires. So the open end or discontinuity changes the electrical properties of the region, and this change in the electrical properties cause the radiation to occur. So here I have shown a guided medium transmission line connected to a generator which is opened out at ends. This opened out discontinuity of the transmission line causes the radiation. That radiation contains electric and magnetic field lines, where the electric field lines are indicated in blue color and magnetic field lines are indicated in red color. So any discontinuity can cause radiation. A curved discontinuity here, a discontinuous structure in the conducting material, a termination in the conducting material, any truncation in the conducting material, any bend observed in this material can cause radiation, and antenna mechanism of radiation thus exists whenever there is a discontinuity in the structure. Looking into the different types of antenna, here I have displayed only a few antenna types which are basically used, like wire dipole, loop, wire monopole, Yagi-Uda array, horn antenna, microstrip patch antenna, cone reflector antenna, parabolic dish reflector antenna and slot antenna. And furthermore, classification also I have given along with some applications. BIP or monopole antenna, normally used for small radio and vehicle applications. Dipole antenna, which can create powerful signal in a restricted space. Yagi-Uda, a high gain antenna, which is used at multiple frequencies with more directional properties. Loop antenna, commonly used for TV and RFID systems. Dish antenna, which is again a high frequency, high gain antenna used in TV and sound. To have a better understanding of the antenna where it is used, we have to know where the observation of the antenna is taken care of. We are aware that antenna radiates in free space. In this free space, which is the region of more importance? So, to know which region of antenna radiation is of more importance, we have to divide the antenna radiating region into field zones. So, this class, let us see what are different antenna field zones. This antenna field zones can be defined based on the dimension of the antenna and distance at which the antenna radiation fields are being observed. So accordingly, the relation between the dimension of the antenna and the distance at which the radiation mechanisms are observed plays a major role in defining the different regions of antenna field. We have three antenna field zones described. One is reactive field zone, other is radiating field zone, followed by far field zone. The first two fields, called the near field zones, one being the non-radiative reactive field zone, is present very near to the antenna, followed by radiative Fresnel near field zone present next to the non-radiative reactive near field region. And third region is far away from the antenna structure, several kilometers away in the free space. So, the first field, reactive near field, is at a radial distance less than 0.62 root of d cube by lambda. The second field region, called the radiating near field region or the Fresnel region, lies between 0.62 root of d cube by lambda and 2d squared by lambda. And third field zone, far field or Fraunhofer region, lies with a radial distance very much greater than lambda, where d is the dimension of your antenna, lambda is your operating wavelength, this capital R is the radiating distance from the antenna. Far field region is of most importance because this region determines the antenna radiation pattern, how the fields are distributed in the field space, how the electric and magnetic fields are distributed in the field space. And antennas are used in communication, that is in wireless communication, for long distance applications. So, as most of the antenna applications are related for long distance wireless, far field observations are of more important. So, far field region is taken to understand or to find out how the antenna radiation exists at several kilometers away from the antenna placement, where the antenna is placed. Here I have shown a diagram to show how the radiation field varies with the distance. In the region near the antenna, the field distribution cannot be determined clearly, or otherwise you can say it is not directional. As the distance moves in the far field region, the pattern becomes more directional. That is, in a particular direction it has got more radiation, while in the remaining directions the radiation diminishes. Here is an example of motor where the signal from the motor changes in its field radiation with the distance. Another example is a loudspeaker. The sound energy from the loudspeaker changes its existence in the far field. So, this class I have introduced how an antenna is can be realized, how we can define an antenna, and what are the different field zones of antenna observation. In the coming class, let us discuss the basic parameters related to the antenna and see how the parameters are going to define the antenna structure in the form of design. Thank you.